Today, there are many modern frameworks for Java web applications like Spring Framework, Play Framework, Apache Struts, and Vaadin. One thing I can tell you is that all of them are built on top of the Java servlet technology and they run inside servlet containers like Apache Tomcat. Java servlets form the bedrock of Java web applications. Servlet filters are a very key component of that technology. Welcome to my channel. I'm called Ben. Thanks for joining me today. So I want to talk about a very interesting topic called filters. So what are filters? Filters are a concept in Java servlet technology that play a specific and flexible role during request processing. They can also be applied optionally. All of Spring security revolves around servlet filters. All implementation, authentication mechanisms, all authorization revolves around the concept of filters. And I promise you that a concrete understanding of servlet filters will turn out to be one of your best investments. Sometimes to understand complex concepts, I find it very helpful to use metaphors or analogies to compare what I'm studying with a real-world scenario that I might be very familiar with. This helps me really grasp the different concepts in a more intuitive manner. And that is what I'm going to do in this video. I'm going to use a real-world scenario that I hope is familiar with all of you. This helped me understand the servlet filters concept very concretely, and I hope it will do the same for you as well. So let's get moving. Think about the last time you applied for a job. You probably had to do it on a job application tracking platform or an online tool like LinkedIn. However, for the purpose of this demonstration, I want to take us back in time. Just for a moment, picture a scenario where we didn't have digital tools. You had to bundle up your documents into an envelope and mail them to the company premises. Some of the documents in this application could be a specific form that you printed out and filled with relevant details, an updated copy of your resume, or academic transcripts, the relevant certifications, and any other documents required by the company. So you bundled all this together into an envelope like I mentioned, and you mailed them to the company, and then simply sat back and waited for a response, or follow up with a telephone call to the front office, or you could receive a call from them saying that we've received your application, please wait for our response. Ultimately, you're waiting for a response about your application. One could say the response will be one of full rejection, full acceptance, or partial rejection. If it's fully accepted, that means that your application is solid, you qualify for the job from the documents you submitted. Basically, they'd like to find out more about you. They'd like to have another talk with you. Another option could be that your application is partially rejected. Perhaps you didn't fill the form well, or there's something else missing that you could easily fix. Maybe you could refill the form and mail it separately. Either way, they send you feedback saying that overall your application is good, but you're missing this and that. You just patch those gaps and your application will be merged together with the updates and it will become valid again. Another third option is that your application is outrightly rejected for reasons that you cannot fix in the short term. Maybe they require a master's degree holder and you are not a master's degree holder. Maybe you're still studying, or they require a PhD, or maybe they require a citizen of the host country. Perhaps the job is quite sensitive and you are not a citizen. Perhaps you're a resident. Maybe they have a policy in place that they do not hire non-citizens for this position. Either way, what this means is that there's nothing you can do in the short term to fix the application, and that will be the end of your journey in the recruitment process. The diagram I have on the screen demonstrates such a process, right from the applicant applying for the job, the documents being mailed to the company premises, and then being processed, and then coming back with feedback to the applicant. So we're going to use this to learn a few things about filters. I believe this will clarify the most fundamental things about how servlet filters work, their capabilities, their options, the powers they have in the application processing flow, and so on. Now it's time for us to discuss our job application flow diagram in more detail. As you can see, we have a couple of players handling different roles in this flow diagram, and each of them does one of a few things that we discussed earlier on. On one hand, we have the applicant that formulates their application and mails it over to the company. And then this big box represents the company, and each of these sections represents a different player or handler inside the company. Here we have 6 players: the front office, the tech recruiter, a couple of engineering managers. We have 3 of them here: EM1, EM2, EM3, and finally the CTO. So the request flows from the applicant. It hits the company premises. Inside the company premises, it starts from the front office, flows downstream through all the handlers, and reaches the final handler. From the final handler, it makes a turn and returns through the same handlers that had already handled it, and then reaches the front office, and it is mailed back to the applicant. So let's focus our discussion inside the company premises, since this is where the bulk of the processing happens. Each of these 6 handlers we see here that we've just talked about does one of a few things. In the previous section, we talked about different possible responses the applicant can expect during their job application process. So I have reflected the actions that cause each of those responses with these small icons over here. So these icons show the possible actions that each of the stakeholders or handlers of the application can perform. And I have keyed them down here such that we can understand what each of the different icons means or what action it represents. For starters, the green tick represents an acceptance of the application. As we saw earlier, it simply means that the application checks out, all the required documents are attached, the form is filled perfectly, and the candidate qualifies for the position based on their resume or their documents. So what happens next is that they will be scheduled to proceed with the rest of the recruitment process. The red check mark here means a rejection. What a rejection means is that maybe one or a few things in the application is not correct, or some of the requirements for the application are not provided by the candidate. So this could be a final rejection or a partial rejection. On one hand, the candidate's application could be rejected for a mistake or something small that they can easily fix and they can resubmit. Either way, the ball is thrown back to the applicant with a response from the company, and they have to fix the application and resubmit. Alternatively, it could mean that this is a final rejection. There are some scenarios where the candidate just doesn't qualify, so the rejection is final, and that is the end of their recruitment journey. The blue arrow represents a pass-through operation. That means that the current stakeholder or handler understands the request, but they do not have any role to play at this current stage. They don't see any need for them to intervene or make adjustments or respond back to the candidate. They just pass the application through to the downstream handlers. The final icon, which is represented by an animated box with dotted borders, means that the current stakeholder or handler is going to do something to the request to enrich it, adding some additional context to the job application such that downstream handlers can benefit from this additional context. Now that we've understood the different actions that each of the stakeholders could take, let's start with the front office. So the front office is the entry point of the job application into the company. Let's try to walk through a few scenarios. Number 1, if this job applicant does not qualify for the job. As we saw earlier, there are different requirements and the applicant may have overlooked these, or the company may not have clarified these. For instance, if the company needs a master's degree holder, so the applicant will formulate the application and mail it over to the company. This request reaches the front office manager. The front office manager is opening all job applications that are coming in. They are empowered with enough information to make high-level judgments on the application, such that if they don't need to send it downstream, they can just set a response and return it to the applicant. So in this case, the applicant applied for a job that needs a master's degree, but visibly from their academic documents or from their resume, they do not have a master's degree. So what the front office manager could do is simply to reject the request up front. So they will send a rejection response back to the applicant. So the application does not proceed downstream. The second kind of rejection that the applicant may receive from the front office is a partial rejection. There are some key requirements the applicant could have forgotten to include in the application, and the front office manager is able to make judgments on this. For example, maybe they didn't include the academic documents, and this is something the front office manager knows for certain that this information is required. So they send a response which is not an outright rejection. It needs additional input from the applicant. Once again, the request does not go past this point. It does not go past the front office. The front office manager writes a response and mails it back to the applicant. The third and fourth kind of actions are quite similar, and they all involve sending the request downstream for the other handlers to take part in the processing. So in this case, looking at the green arrow action here, this is where the front office manager has checked the request, validated it, and made sure that everything checks out and the candidate qualifies, and there's nothing they can add or remove from the request. So what they do, they forward the request without doing anything to it. And then the final action the front office manager could potentially take is enriching the request. For instance, maybe the candidate has applied and everything really checks out. However, there is additional information needed that the candidate does not really need to provide. The front office manager could just fill it out to provide additional context for the downstream handlers of the application. It's just additional information that helps the company internally to process the application more effectively or efficiently. And finally, we're done with the front office and the application makes it to the tech recruiter's desk. Again, the recruiter has one of four actions to take. One, they could just accept the application and schedule the applicant for an interview. Two, they could reject it because they know more than the front office manager. They are the tech recruiter. As a matter of fact, they're the ones that advertise the position. Maybe the candidate has a master's degree in IT. However, a master's degree in software engineering or computer science is more preferable. Based on the skills of the candidate on the resume, their level of experience, they might decide that a master's degree in IT may just not cut it. If the candidate had maybe a certain number of years of experience, it could make up for the shortfall in the master's degree. However, these fewer years of experience coupled with a degree just doesn't cut it, and they reject the application. In this case, they will have applied the second action item, and the application will not make it downstream. None of the EMs will receive it. Definitely the CTO will not receive it. The tech recruiter has decided and sent a response back to the applicant. So the response passes through the front office manager. Maybe the front office manager sees, oh, well, I couldn't make a decision on that. So let me just formulate an appropriate response for the candidate. Another possible response the tech recruiter could take is the pass-through response. Maybe they see the application and they reach a point just like the front office manager where they can't make further decisions and they just let the application pass through to the next handler. At this point, according to the tech recruiter, the candidate checks out. Everything is good and they are happy to recommend the candidate to the downstream handlers, in this case the EMs or the CTO. So they just do their checks and let the application pass through. The final action the tech recruiter could take is again similar to what the front office manager did and make some changes on the application. Perhaps in their resume, the candidate mentioned that they worked in a certain place from this time to this time. Maybe the candidate said 2010 to 2022. However, based on context, the tech recruiter knows that, well, they really meant 2020 to 2022. So this is something that the tech recruiter would know, because definitely they might have spent some time interacting with the candidate while sourcing for candidates for this position. Then they can just make that update and forward the request downstream. And this is information we could say is a result for the tech recruiter because they interact with the candidates more often. Front office managers may not have that context, and neither do the rest of the downstream handlers, but they need the information. Otherwise, they'll be confused about how to handle this application. And now we are done with the second handler, that is the tech recruiter. So let's look at what happens in the next step. Things are getting more technical, the checks are getting more detailed. At any one time, typically companies are hiring for different positions. Different engineering managers are getting approvals for staffing their teams. Maybe one needs a DB engineer, the other needs a product manager, the other needs a tech lead, the other needs a junior software engineer, and so on. So where we've reached, we have about 3 handlers. They're all similar. So assume that each of these is an engineering manager for a different team. And perhaps engineering manager 1 did not really request for any candidate. Engineering manager 2 needed a junior engineer, and engineering manager 3 needed a tech lead for his team. So when the tech recruiter forwards this application to EM1, EM1, out of all the 4 actions, remember, each of these stakeholders or each of these handlers will take one of the 4 actions. So EM1 cannot accept, they cannot reject, they can pass through the request because they do not really need anyone, all right? And they don't need to add anything because they are not concerned. So they just look at the application and let it pass through. Then when we reach to EM2, EM2 is the one that needed a junior engineer, right? So he'll look at the request, maybe he'll accept it, but is this application meant for his team? Is this candidate suitable for his team? For the purpose of proceeding downstream, let's assume that EM2 lets the request pass through because they required a junior engineer, but this resume is for a tech lead. The request goes to EM3. Perhaps this resume being for a tech lead, EM3 was looking for a tech lead. They look at the resume and they have 4 options, as all the other handlers have. They can accept the request after inspecting and validating the qualifications of the candidate. They can reject the candidate based on certain parameters that the candidate doesn't really meet according to the EM. So in this case, the EM could be looking at the specific experiences the candidate has, details of what kind of projects they have done, and details of the kind of problems they have solved in the past. So when the EM deems this applicant to not be qualified, they may have the option to reject. So when they reject the candidate, the application will not proceed downstream. They will just forward the response back through the other EMs, back to the tech recruiter, back to the front office, who will formulate a final response and mail it to the candidate. But they could also find that the candidate is not meant for their team. Maybe there was need for a tech lead, but the CTO is the one that required it. Perhaps the CTO required a tech lead for a new team he's formulating. Who knows? But the EM3 definitely sees that, well, this doesn't really work for me. I'll forward this to the CTO because this application looks like something he might be interested in. So the EM3 forwards the application to the CTO. And then in the final scenario, maybe the EM, he adds a comment on the application, adds a recommendation. In a way, this is enriching the application. And then he forwards the application to the CTO. Finally, we're now at the end of the application processing flow. Here's our CTO that receives all the applications that make it to his desk. All the applicants that maybe didn't qualify for a specific team, but they have a really strong resume, and the CTO might be interested in looking at this, then the EMs forward the candidate's application to him. Or the tech recruiter made this decision and added a comment. Remember that there is the enriching action here. Added a comment in the application such that the EMs can decide, all right, this is an interesting one. Why is it coming to my desk? And the tech recruiter says, oh, well, I think this is very interesting for the CTO. And the EM says, okay, I understand this request. Let me forward it. It goes to EM2. EM2 says, well, this doesn't work for me because I'm looking for a junior engineer, but let me forward it to the next one. All the way to the CTO. So the CTO finally makes a decision about how to handle this application. So he'll do one of the 4 things also. Perhaps he will accept to meet this candidate. I'll respond like, well, okay, schedule this guy for an interview, book time on my calendar. I'd like to talk to him. And from this point on, the response for the application starts making its way back to the candidate through each of these handlers, one by one, until it reaches the front office manager, and then it is mailed to the candidate as a final response. Welcome back from that demonstration of how a job application is processed through our hypothetical recruitment pipeline. I can tell you with confidence that the scenarios we walked through are nearly identical to how servlet filters work. So let's go ahead and map out these similarities side by side. First of all, the large box over here where all the action happens and where all the handlers exist, which we call the company, represents the web server. In our case, the servlet container like Apache Tomcat. Secondly, moving over here, we have our applicant who formulates a job application request and mails it to the company. This represents a web client that is capable of sending HTTP requests to the web server. Examples of this web application client could be a web UI on which a user is browsing, or such web application clients like Postman or CURL, or it could also be a programmatic client like a backend server calling other backend server APIs. Then we have the job application request being sent by the applicant, represented by this mail icon. This maps to the HTTP request, as well as the job application response received, which maps to the HTTP response. Thirdly, we have a subset of the company employees that form up the tech recruitment pipeline, or the front office manager, the tech recruiter, all the way to the CTO. They are responsible for processing the job application from the time it hits the company premises to the time a response is sent back to the applicant. As you can see, each handler sits at a unique position in the application processing pipeline, playing a designated role when their right time comes. And in fact, each one remains dormant before or after this particular time. Therefore, a recruitment handler maps directly to the idea of a servlet filter, which intercepts an HTTP request and performs its designated role on the request and response. One could ask a question: are the tech recruitment handlers the only employees in the company? The answer is no. However, our analogy dealt specifically with recruitment in the tech department. If the company was hiring in the finance department, perhaps instead of having an EM, we would have a finance manager. And instead of having a tech recruiter, we would have a finance recruiter in the pipeline. A CFO instead of a CTO at the end of the pipeline. Effectively, when our hypothetical company is hiring for both finance roles and engineering roles, we would end up having a tech recruitment pipeline, like we've seen, and another finance recruitment pipeline, and maybe a third one called the HR recruitment pipeline. Each specific department would have a unique pipeline to process their job applications. This specific analogy maps directly to the concept of servlet filter chains. A servlet filter chain is a contiguous block of filters which together form a single sub-pipeline within a servlet application. A servlet application can have 0 or more filter chains, and each of the filter chains can have 0 or more filters in them. This is similar to having different recruitment pipelines for different departments. For instance, we had the tech recruitment pipeline, the HR recruitment pipeline, and the finance recruitment pipeline. As a matter of fact, one could say these are the tech recruitment filter chain, the HR recruitment filter chain, and the finance recruitment filter chain. We've seen that depending on the position a candidate is applying for, a different recruitment pipeline will be activated or selected to process the application. Likewise, depending on the attributes of a specific HTTP request, a different servlet filter chain or different servlet filter chains may be selected to process the HTTP request. For instance, we could create one filter chain to target all HTTP GET requests, and then we could configure another one to only target post HTTP requests. Effectively, this reflects our desire to apply different validation rules to each type of HTTP request. However, that is not all the power that servlet filters give us. Remember that in the company recruitment, some handlers could be active in all the recruitment pipelines. For instance, we have a front office manager that receives all applicants from tech, finance, and HR, and then routes all these applications to the appropriate recruitment pipelines. It's the front office to decide where this application could go. Finally, a programming tutorial does not really make sense without, well, programming. So I hope you're very excited like me for the next phase of this tutorial, where we're going to get our hands dirty and do some coding. And this is going to be very interesting, especially after we've looked at all these analogies, mapped them together with servlet filters, and fitted everything in. Now we're going to see all this in action and do this practically. So during the course of these demos, I'm going to refer back to this analogy, talk about the recruitment pipeline, talk about the company jobs, talk about the okay, I give up. Just come on over. So we're going to start by creating a simple Spring web application, and I'll move on from there. So I'm going to make this, I'm on the Spring initializer or on the web start.spring.io, I'm going to choose Gradle Kotlin as my build system. Language is Java. Spring Boot version, let me just choose. Yeah, anyway, the default is okay. It doesn't really matter. These are very old. What we're testing is really very old stuff. It's bound to be there in any Spring version, really. So we have group. I'm going to call this. Then the artifacts. Let me call it filters. Demo project for filters. Okay, it's a jar and Java 17. That's okay. I'm only going to add the Spring Web dependency. That's all we need. We don't need any more than that. So let me generate the project. Okay, it is called filters.zip. It's all right. So now I'll go to the IDE. I'll say open a project, go to downloads, look for filters. Okay, then I need to first unzip it. Let me rename it to filter demo, and then I'll come back here and I'll look for filter demo. There it is. I'll open the project, trust it. Yeah, I think here is our project opening up. It's going to be downloading dependencies, and that might take a while. So what I'll do, I will just let it play out and get to it in a bit. There we go. The project has completed downloading all the dependencies, and it's ready for us to explore. So let's just open the sources here. By default, we have the application class. It's just basic as they come, and there is nothing else here. So what I'm going to do, for starters, I'm going to create a package called controllers. And I want to create one controller there. I just want us to see the application working. I'll call it filter controller. We're going to annotate it with REST controller. Then here I want us to create get mapping to, let's say, API take application. It's really very arbitrary, but I wanted to match our earlier analogy. I wanted to match our earlier analogy, so I'm going to say public string file application, and it takes nothing and simply returns a text application processed application reached controller. So that's all ready, and I'm going to save that and run the application. So let me just run filter main. So I just want us to test this from Postman and see that we are receiving a response. So the application has started successfully. We can see it's running on port 8080, and we can go over to Postman, and I'll start. Okay, localhost. That's 8080 API take application. So let me send a GET request to it. We received the response from the controller, application reached controller. So this is good because that means we have a working Spring application. So now let's go over to filters and start showing what we've been learning all along. Before we go into filters, I just want us to add some good logging capability here because there's some things we're going to test by observing a log in the terminal. So we need to have that in place so that we don't have to rely on what is returned to the client. Some things we shall see them based on what is in the logs. So I'm going to add a dependency, a compile dependency on Lombok because it just gives some really good logging capabilities. Lombok, project Lombok. Okay, so then I need to add annotation processor dependency. It will still be object Lombok. So I think that's it, and I need to add the configuration. That should be good. Let me restart the project. It has started, so the dependencies are good. I hope we can access the logging annotation from Lombok over here. So if we add a log here, all this is really not about filters. So this is simply setting up the project to be able to do the demo we want to do. So I'm going to log here. Request received in controller. That should be good. Let me restart it and test that. Right, started pretty quick. So I'm going back to my postman and I send a request. We received a response, and if we look in the logs, we have here the log request received in controller. I find this hard to locate pretty quickly, so I'm going to add here something to just make it easy to locate the log. Let me restart it. So if we send the request again, it should be very easy to locate the log. Here it is. Great, that's it. So in a servlet application, a filter is simply a class that implements the filter interface. So before we do anything, I'd like us to take a look at the filter interface and just explore its signature and understand things that we've been discussing before, either in the analogy or about the filters themselves. So I'm going to search for the filter interface. Here is the filter interface. So let's take a look at it. You can see it's inside the Tomcat jar, so that means it's a pure servlet interface. It has nothing to do with Spring at this point. So the interface has a few methods. One of them is init. This is the method that is used to initialize the servlet filter, and it takes a configuration. So all this is really not very important to us. As you can see, this particular filter method is a default method, so we don't even need to bother with it because it's not mandatory to implement it, especially if we're dealing with filters inside Spring. The most important method is called doFilter. As you can see, it's mandatory to implement it. And the destroy method is another lifecycle method similar to init method, and it just takes care of destroying the servlet. This is where you do any cleanup. So what I'll do is to come over here and create another package called filters. No, not filters. Okay, I already have filters, so I don't need to create a package. I'll just come directly here and create, let me call this front office filter. So I have a class over here. I'll say it should implement filter. Where is the filter? It's kind of just hidden in the list of so many methods, so many classes. So I'll just leave it at that and import it directly. Alright, so our class here implements filter already. This makes it a servlet filter, and as you can see, we only need to implement one method from the filter. Right, so this is basically what I wanted us to talk about, the signature of the filter interface. We implemented the doFilter method. So the doFilter method is the real actual workhorse of any filter. In the doFilter method is where you do anything that filter is supposed to do. So what happens is it receives the servlet request, the servlet object, then a filter chain. So servlet request is the actual request that is coming into the servlet container, and this is basically what we do when we invoke our API over here from Postman. We're sending a request. So when the request reaches the servlet container, like we saw before, the servlet container will first invoke a filter chain that qualifies to process that request. And the filter chain has a suite of filters inside it that do what they're supposed to do, and then sort of pass the request on down the filter chain. So in the servlet container, the servlet response is created, even if it's empty, but it's created at the beginning of the request, so that we don't have to return a response object here. So this response object, it can be manipulated from inside the filter or a controller, and it will be streamed back to the client based on what you do inside any of these filters or controllers. So the filter chain is the chain inside which this servlet filter is being executed. We talked about this at length, and we're just seeing it practically, but I hope it makes sense. If it doesn't, it's going to make sense as we see as we get more practical with this example. So what I can do over here is I'm just going to log a message here, log.info. Let me add my log markers. Front filter intercepted the request. So I have this log over here. This is all we should care about now, and I just want to show you what is going to happen if we restart this application. We're not going to see that log being printed, but I'll explain why. So I have my request received by controller here, but this log has not been printed, and the reason for that is because we're dealing with a Spring application, okay? And the Spring application requires that every object inside it is exposed as a bin, and we simply haven't done this. So if we add here, if we make this a bin by adding the a stereotype annotation here, making it component means that it will be subject to component scanning, and it will be picked up by the Spring initializer, and it will be in the context when we run the request. So let's see what changes. All right, the application has started, so I can come over here and I run that. So response is 200, but again, we don't have anything returned over here. So I'm also going to explain that in a bit. Yeah, just keep that in mind. But I wanted to show you that the filter log is now printed. So here we have front office filter intercepted, and yeah, we have front office filter intercepted. So that proves to us that just by creating an object that implements the filter interface, we create a servlet filter. But that doesn't mean automatically it will be used, because Spring deals with bins, and for something to be a bin, it needs to be annotated. It needs to be picked up when the application is starting up and inserted into the application context. So when we added the component annotation, we made our filter into a bin. So there might be other questions as to why we had to make this a bin, yet this is a servlet filter. But basically, I'm going to explore this further down the line as I talk about other concepts. But otherwise, this is sufficient for now. We just created a bin of type filter, and when it made it into the application context, the servlet container was able to invoke it during the course of processing a request. So then the question comes, how come we didn't receive a response? And even the controller didn't log. The controller didn't log, and it didn't get to return the response it was returning. So let me just answer that question. So what has happened here is that this filter received a request, and it can actually print the request here. It received a request, and what it did is it did what it had to do, because we designed this filter simply to log something, and after logging there's nothing else it does. So what you should remember is that all filters, any filter we have, exists inside a filter chain. And according to the design, this is basically an implementation of the chain of command design pattern. So according to the design, each filter receives an instance of the filter chain within which it is executing. And the servlet container will go on to invoke any filter in that filter chain in the order in which they appear. So, and after invoking the last filter, it will then invoke the servlet that is supposed to process the request or the service. And in our case, the request will go direct to the filter controller. So what has happened here is that we've not chained in the rest of the request. That means that the request remains in this filter, and Spring simply responds. Actually, this is the servlet container simply responding back to the calling client without proceeding down the chain. And we are going to fix that by updating this filter to show us exactly how the chain of command is supposed to work when it comes to filters. So let me just run this again. I want to see what is printed over here. So you can see we have a request object here and the response object here as I updated. So what a filter is supposed to do after doing what it's supposed to do, let's assume that logging is the only thing the front office filter is supposed to do. So after that, it's supposed to invoke the chain, the do filter method on the chain, pass in the request and the response. Then behind the scenes, the chain is going to ask its internal storage, what is the next filter supposed to be invoked after front office filter. And if front office filter is the last filter in the chain, then it will invoke the filter controller. So let's just restart this and show that this is actually what happens. Alright, it has started, so I'm going to invoke it here. So now you can see we have application reached controller response returning here. When we go to the logs, we can see that the front office filter is intercepted. As before, it does what it's supposed to do, in which case only logging, and then even the request received in controller log is printed. That means that the request proceeded to the controller because we added this chain invocation. If we don't add this, the request will stop on this filter, and it will not. It's like the chain has broken here. So that is something that could be a very big mistake and cause bugs, a bug that is very hard to trace, especially if you don't really understand this very well. So I'm going to leave this at that. So suffice it to say that the chain contains 0 or more filters inside it. And in this particular level of execution, there might be 0 or more filters before the front office filter and 0 or more filters after the front office filter. All that is known by the filter chain. The front office filter has no knowledge of what other filters are there. All it knows is that it's been invoked, it will become active, and then become inactive after it has finished executing, after passing the chain of command back to the filter chain. So now let's do something else. I'm going to come over to the controller and I add a second controller endpoint, public string file application. So let me just change this to file tech application, file finance application. As we saw earlier in our demos or in our analogies, we're using the similar terms over here. So I'm going to create a get mapping here, API finance application, and over here I'll log info. I'll call it, all right, let me say finance request received, and then here I'll say tech request received in the controller. So tech application received, finance application received, controller. So let me just restart that. I want to show you that the filter we've created here is going to be invoked no matter which endpoint is called. So I'm going to call again, tech application reached controller, and here we can see front office filter intercepted the request. Then if I change this to finance and I invoke it, we receive the response here. And then over here you can see again the front office filter intercepted the request and the finance request controller was invoked. So this simply shows that the filter we've created as is applies to every single request that goes to the servlet container. And this is very important to notice because from what we talked before, there has to be a way to segregate which filters are active and when. But that is something I'm going to cover shortly. So just keep this in mind that the filters apply to all requests. And then another concept I want to show is that after chain.doFilter, after the filter calls the rest of the chain, I want to show what happens after that invocation, because as we saw earlier, filters have access to both the request and response. So when the response is coming back, the filter should be able to also see it. Front office filter intercepted response. So let me just remove this. It's not really that useful for now. Let me remove those logs of the request and response. Request. So front office will intercept the request, and after the filtering, it will intercept the response. So I'm going to restart again and test. We're invoking the finance application here. Successful. So if you look at the set of logs, you'll see front office filter intercepted the request, finance request received in controller, then front office intercepted the response. Right? So actually the front office filter sits between the request flow and the response flow. As we saw in our diagrams during the analogy, we noticed that this request goes through the filter chain to the end, and when the controller is invoked and the response is making its way back, and the same filters are going to be in the path, the same chain will know that this is the response coming back from a request. It may not know the filters that exist after or before itself, but the chain knows which filters are going to be invoked before or after. So this is again something I wanted to show you. Just also keep that in mind, because we are going to use these features as we go along. So basically what we've done here is to show the most basic way to create a servlet filter in a Spring and inject it in a Spring Boot application and see it actually getting active during the request processing. So having looked at this, I must mention that this is not the only way to create a servlet filter, and we are going to see others, especially when you need when you have more complex needs, there might be other things you need to do. For example, I mentioned earlier, selection of filters or activation of different filter chains based on the request parameters. So we've not looked at this here. What we've done is to create a filter in the most basic way possible, and without any further configuration. The filter is applied to all requests that are coming into the servlet container. So from this point on, we're going to start making some customizations and see other ways of creating filters that give us more power on what we can do, and how we can achieve specific outcomes we want based on the feature we're building. So let's move on to that. I hope you remember that during the analogy we talked about how filters have certain power with them. For instance, they stand between the request coming from the outside world and the controller that is going to process it. So a filter can do one of several things that we looked at when we were looking at the chain or pipeline, the recruitment pipeline. Like the front office filter can intercept the request and return a response without forwarding the request down the chain. Or it could get the request and make changes to the request object before forwarding it down the chain again. And the final action that we looked at is when a filter just forwards the request. So what we've seen here is an example of a filter simply forwarding the request without touching it, and it goes down the chain, and then it comes back to the same filter when the response is returning, and it proceeds back to the client without this particular filter doing anything to it. And the logging is simply a side effect. It doesn't affect the request, nor does it affect the response. So I want us to look at those other a little more complicated scenarios, and we're going to start by seeing how the filter can actually return a response without forwarding the request down the chain, because this is within the powers of the filter. It can decide what to do with the request based on what it knows or what it's designed to do. So let's say we want to return a success response in this front office filter. Maybe the application was received and the front office is able to make a decision on it. So we want to simulate that scenario. What we need to do is simply to write to the response, because the response has a stream to which we can write, and this response will be streamed back to the client. So I want to say the front office responded. Okay, so I have that. We can just remove this filter, the chain call, and we see what happens. So if I restart this application, basically this is not a good design by any means, but we are just demonstrating a concept, and I'm going to correct this code later on to make it more meaningful. So you can see I've received front office responded. If I go back to the logs, you can see that front office filter intercepted the request, and front office filter intercepted the response. So after this, the chain is not called. And remember before, when we didn't have this call and we didn't have this, what happened is, and also we didn't, okay, it doesn't matter, this is just a log. When we didn't have the chain invocation and we didn't have the response written in from the filter, let me show you something. There was no response here. So what it means is that without this response, the response will be empty. And without invoking this chain, then the request won't be forwarded down the chain to other filters or to the handling controller, right? So what we've done is simply short circuit the request. The most important thing here is the chain.doFilter method call. It didn't happen, so the request didn't proceed down the chain. And without adding this line, we'll just get an empty response. The servlet controller will just, the servlet container will simply return an empty response. But we've changed that by adding a response here. So you can return an empty response or a specific response that you set from the servlet. But as long as you don't call the chain.doFilter, the request will be short-circuited and it will stop at the front office filter. Then the servlet container will return whatever response is inside this object back to the client. Before we didn't have anything here, that's why we saw an empty response. But now we've added, we've written something to the response stream, and that is what is returned to the client. So like I said earlier, you wouldn't probably want to do this because then it will make your application meaningless. Why, if you want the filter to be the one responding to requests, why not just create a controller to do that? You don't need a filter to do that. The purpose of a filter is to apply cross-cutting constants across requests that it matches, such that you don't have to have controllers doing these things repeatedly in each of their code files. So in this case, we need the front office filter to do something that is universally meaningful across all the controllers it applies for. And simply logging something is not that meaningful, and neither is just responding to all requests. So what we're going to do, we are going to come over here in the request and make the request have a certain header that will signal to the front office something, and they can make a decision whether to forward the request down the chain or just respond back to the client. So let me say X inquiry. So this one we shall toggle it between true and false. So this will mean that the request coming in is actually not an application, but someone is inquiring something about the application, and the front office manager could be able to respond to that. So I'll come over here and handle it. One more thing I'll mention here is that since this is just a bare bones servlet concept, the filters received a servlet request and a servlet response, and as well as a filter chain. These are all just really rudimentary object types, and we may not have much to do with a servlet request inside an HTTP service. So remember, servlets don't just deal with HTTP. They could be written to serve other kinds of protocols like UDP and so on. So we're dealing with HTTP requests, and I'm going to make sure that we have these objects converted. So let me see. Let me just convert the request to HTTP request type. I'll just cast it, because if you look at the servlet request, it's just an interface and it has implementations, and HTTP servlet request is one of them, because then we can't just access headers in the, remember, I don't know if UDP protocol has a concept of headers, but all I know is that this is an HTTP concept, and if we don't convert this to an HTTP request, we'll not be able to access the header that we set here. So I'm going to have my HTTP request here, and I want to check if the request is an inquiry, and I'll do that by checking the get header. Okay, the header name is X inquiry. Just for the record, if we try to access the header from the raw request, I don't think we'll be able to get it. So that method doesn't exist on the raw request object, so that's why we had to cast it. And even if we try after casting it and we still try to access the original object and we do get header, you'll see, but this is just IDE nonsense. So you can see that it had to first cast the request to an HTTP servlet request because it got a hint from what we did here. Either way, I hope I've made the point, and now I have the is inquiry object. So to just prove to you that it is actually the same, I'm going to return it back to the client. So is inquiry is there. So I'm going to restart this. I'm going to try and send a request. Inquiry is false if I change it to true. inquiry is true, so we have that, and I'm going to do this. I'm going to add a condition that if value of is inquiry, it's just a way to convert it to a boolean, then we are going to write this response, yeah, over there. So I have, say, use a primitive boolean expression. Okay, right, so I check if this is an inquiry, and if it is, I just respond to it without forwarding the request downstream. Okay, let me remove this so that the response was an inquiry. Let me remove this because I want to make something more meaningful. So front office responded because this was an inquiry, and now this makes sense. And if it's not an inquiry, then the front office will forward the request down the chain. So now we can move this call over here and uncomment it. Either way, when the response, we don't need to make the response come in. We don't need to log this response if it's only the front office filter responding. So I'll move it inside the case where we call the chain so that it makes sense. So now I think this is something better. We have a request coming in, it's intercepted by the filter. The filter checks if it's an inquiry, in which case it has the authority and the information to respond directly to the client. And if it's not an inquiry, then its duty is to forward the request down the chain. So this is conditional evaluation of a request in the filter, and this is just one of the things I said a filter is able to do. So based on what it knows, it has decided to handle the request itself in one scenario and forward it down the chain in the other. I think you'll agree with me, this is more meaningful than just responding to all requests. So I'm starting this up again, and I'm going to test this. So if it's an inquiry, we see that front office responded because this was an inquiry. So if I change this to false, we can see that finance application received in controller. So this is really just adding some bit of dynamism, and while exploring more things that filter can do. And we don't really need to look at the logs anymore because I think what we've been doing here makes it pretty clear. Or maybe we can check what happens if this particular header is false. Maybe it will fail. Oh yeah, so if it is false, the Boolean conversion will, if the field doesn't exist, the Boolean conversion will take care of that. It will just make it false. That's the default value of Boolean. So there's no problem, our application won't break. So I'll just keep it like that. Check our initial test. All right, so that worked. So we've looked at a scenario where the filter passes the request downstream as a pass-through operation. That was at the beginning. And then we looked at a scenario where the filter rejects the request or responds back to the client without forwarding downstream. And this is what we did here with the conditional evaluation of the is inquiry field. And this is something, based on this same principle, you can reject the request by throwing an error or returning an HTTP response with error. And so this particular example applies to both accepting, rejecting, and partial reject and full reject that we looked at. What we haven't looked at is the scenario where the request is enriched and then forwarded downstream. So what I'm going to do, I'm going to, if the request is an inquiry, the front office will respond, but then if it's not an inquiry, the front office can enrich it with some information. Maybe, let me see. So every request has attributes, as we talked about. So I'm going to set an attribute on the request, and maybe let me set something like front office. Okay, let me set something like comments. All right, so just let me get request to get attribute, comments, and I'll assume this is a list, and just cast that and then cast this to a list. So I'm assuming that everyone that touches this request is going to leave some comments, as we had seen in the analogy, and the controller will be able to look at these comments, or even any other downstream filter will be able to look at these comments. So let me just log the comments here. Logged info, comments on application. I'll just print the comments here so that we show that each filter is able to see any state changes that happen in the request during the processing, from filters that came before and filters that come after. This is I think the only connection between the filters, and since filters don't know each other, so similar to the recruitment pipeline, each handler in the pipeline is able to see comments on the application, in which case, in this particular case, it's the request. The HTTP request contains some bit of attributes. One of these can be comments, and each filter should be able to look at them. So here, I'm going to log this here, and then let me say that I add a comment add this approves of this. I think that works. Then I'm just going to reset it back here. Comments. Yep. Set attribute. It's actually a map comments. Yeah, so this is the attribute that we are adding, or we are updating. So this is how we are enriching the request, and it will continue further down. And I want to try and run this, and we see when we come to the finance application, we can inject the HTTP. We can inject the HTTP servlet request here, and we print the comments. Oh, okay. Print the request attribute. Get attribute comments. Alright, so I have this, and do we have to return it in the response? Received in controller with comments. Okay, let me do that. Alright, so now there we have the enrichment, so we can test it out. Front office is ready. Let's just run that. Application started. If we come here and we send the request, front office responded because this was an inquiry. So if we say it's not an inquiry, and we run it, oh, we have an error. So we're going to look at what that error is. Okay, I get it. We assume that comments is already existing in the attributes map, but it is not. So for each filter, we need to add an extra step. If comments is null, then comments is new array list. Yeah, I think this one will solve our problem. That was just a small bug over there. Right, we come over here. So finance application received in controller with comments. Front office approves of this. Great. So now enrichment is working. And remember, this is the controller responding, not the filter. So that means the request proceeded, but it was enriched with comments from the front office. If you look at it here, front office filter intercepted the request. the comments are empty at the front office level. So front office adds its own comment. Front office approves of this. Then the front, the controller, yes, the controller, sort of receives the request and sends a response, and the response goes back through through the front office filter. To drive this point home, I could just simply whip up another filter over here to add another comment. Just call it another filter. So the request has started. So when I send the request over here, you can see finance application received in the controller with comments. Another filter commented, front office approves of this. So the order really shows the order in which the filters are invoked, and this is something that I'm going to talk about briefly, but I think you get the point. So by the time front office is invoked, another filter will have been invoked, and comments on application, another filter commented. This is what front office receives, and yeah, that's great. So you might be wondering, okay, so if front office is supposed to be the beginning of the filter chain, so now we have another filter that is coming before front office. Isn't this not something, didn't we want the order to be maintained? So that's a good question, and I'm going to cover it just in the very next subsection after here. And we're going to see how to enforce some ordering of filters now that we're starting to get more filters. And this was just a test filter. We don't really need it here. I can delete it, but I'm going to have other filters like EM or CTO, and we are going to try to enforce the ordering, and I'm going to show you how to do this. So now let's go ahead and create other filters in our earlier recruitment example, just so we drive other points home. So I'll just come over here, and after the front office, there was the tech recruitment filter. Tech recruitment filter. And then, okay, to make things a bit more organized, I'll create another package here, tech, and then another for finance, and I'll create another for HR. So just to keep things in order, I'll move the tech recruitment to tech, and I'll leave the front office filter here because it applies to all based on our examples earlier. So let me just do what we know we must do. Make this a bin, implement request and response. All right, so this is it for the tech recruitment filter, and then I'll come to, maybe I should add a log here as well. So now, let me just copy this to avoid typing out everything. Then I will create another one, EM1 filter. I add EM2 filter. I create EM3. Then I come here, I create CTO. CTO viewed. Yep, so we've created 1, 2, 3, 4, we've created 5 more filters, and I'm going to restart this application and we see what happens. So let's go back to tech application. We send a request. Tech application reached controller. So now let's see what happens in the logs. Front office field intercepted, great. CTO intercepted, or in our example, CTO was at the end, but now it's at the beginning after front office. So EM1 intercepted, EM2 intercepted, EM3, then tech recruitment field intercepted, but this was supposed to be after front office filter. So you see the order is, according to us, it looks quite random because we don't know exactly how these requests are being intercepted. So I come over here Yeah, the order remains the same. It's different from, it's not the order we want, but it seems to be pretty consistent in its randomness. So how do we order these filters? So it so happens that a filter is just a bin, as we saw earlier, and you know very well that when you create bins, maybe in a configuration object in Spring, you usually leave the ordering bit to the Spring application context. And in case you want to enforce some kind of ordering, then you need to do something extra to enforce this. Otherwise, the Spring context will simply use their dependencies and the order in which they appear and so many other factors to decide which bin is created first and which is created after a certain bin. But for us, we know the order in which we want these applications, these filters to be invoked. So I'm going to introduce another annotation called order annotation. So I'm going to show you how it works. Let me go to front office. I add an order annotation. So the order is 1. So what happens is the way Spring orders the bins it creates is it gives them the least order. That means that every bin by default is going to be lowest priority. And then the ordering will emerge as Spring creates these bins, and when it encounters a bin that depends on another one, then it will first create that bin. That means the other one will come higher in the order, unless if we explicitly define the ordering, and especially in relative to each other, Spring is then going to respect that. So here I've added order 1. Let me go to the next is supposed to be tech recruitment filter. I'll add order 2. And then we go to EM1. EM1 is order 3. We're really just using the order in which we discussed them in our analogy with the recruitment flow. So this is 4. This was okay. Tech recruitment was 2, EM1 3, EM2 4, EM2 should be 4. EM3 should be 5, and then CTO should be 6. Yeah, so let's, after adding those order annotations, let's restart it and see how it takes effect. Okay, it has started. I'm going to run this. Everything is okay. We come back here, then we see front office filter is first, followed by tech recruitment filter, then EM1, EM2, EM3, and CTO filter last. So basically, the ordering we've applied has worked. And as you can see, this is an important aspect when it comes to filters, especially when it comes to something like security, Spring security, where filters are applied extensively, because you do not want one filter to come before the authorization filter, or if there's a filter that is supposed to check authentication, you don't want the filter that checks authentication to come after the one that checks authorization, because one is supposed to come before the other. You can't have authorization without authenticating first. So this kind of ordering is applied extensively, and we're going to look at this a lot, but for now we're just walking through concepts one by one. So we've looked at the ordering bit. So now let me just like we have the tech, the front office filter having the return path also logged. I'm going to add the return path for each of these other ones here. For CTO, CTO intercepted response, tech recruiter. Now, with this in place, if we restart the application, we'll see each of them intercepts the request on the way back. All right, then let me just do that. Come over here. Now the logs are much more than before. Front office, the recruiter, EM1, EM2, EM3, CTO. Then on the return path, CTO is first because it was at the end. Now on the return path, it's the first. EM3, EM2, EM1, tech recruiter, back to front office, which then forwards the response to the client or the applicant. We've made quite a lot of progress so far, and we're introducing new ways we can manipulate filters and use them. But I want to show you something else that is going to introduce a new problem. We've added comments. We have comments showing interception of the request and the response by the servlet filter. We also added some other thing here to show that the filter can actually intercept the request and send a response without going further in the filter chain or pipeline. So I want to run another test. So now I'm going to invoke the finance. I'm going to send a finance application. Remember, we've just added the tech recruitment pipeline players. So let me do finance. Oh, so if you see the response from finance, it's successful. However, we have comments from all the tech folks. This definitely is not supposed to be how this works. Right, so front office is the only one that is supposed to be here, but tech recruiter, EMs, and the CTO have no business with the finance recruitment pipeline. So what does that mean? Basically, I told you that all filters exist within a chain, and there is no filter that exists alone. It is always executed within a chain, and there is a default filter chain that is created, and all filters that apply to a certain request are added to that chain, and this chain is passed into every filter when it is invoked, such that the filter can forward the request down the chain or when it is done. And one thing I also mentioned is that the way we've created the filters right now is the most basic and simplest way to do it. However, there may be other more complex requirements. One of them we saw is the order requirement. The ordering requirement is something we needed for our application, and we've added it by adding these order annotations. However, one of the other requirements is that we don't want the tech recruitment pipeline to be active during the execution of finance applications. So what does this mean? Now, this is going to introduce something else. We need to know a way to influence the creation of our own filter chains. And this is what I want to show in the next section, such that when we send a finance application, there is no CTO filter in the pipeline or chain. There is no EM filter, all right? And when we send a tech application, then we need to see all these other all these filters we've just created. That's the only place where we need to see them. But we also want to see front office filter in all of these applications, because they are the ones that receive all requests and route them to the appropriate controller or handler. So in the very next section, we're going to talk about filter chains and how to create them or influence them. That's our next complicated requirement that the basic creation cannot do, because according to the basic method we've used right now, all filters will apply to all requests hitting the servlet container. The first thing I'm going to do is to change the way we are declaring our filters and keep them all in one place, because remember, there are different ways of declaring bins for the application context to find them. So what we did is just a Java config annotation-based configuration where component scanning will pick up these bins, which are our filters, and add them to the context. However, the Java config based on configuration classes is a neat way to keep all our definitions in one place, so that we don't keep jumping from one place to the next to be able to have a look at configuration for our filters. So what I'm going to do, I'm going to remove these annotations that make this bin and that order its place in the pipeline. I'm going to create one central place where we are going to create all our filters. So let me just add a configs folder here, create a central filter configuration class, and make this a configuration class. And here I declare different bins. and I'll call this front office filter. And then I'll just return new front office filter all the way to the CTO filter. So my CTO filter here. Yeah, so I have those. Then what I'll do next is to remove the ordering and bin declaration. So now we can manage them from one place, which is the filter config. I have this, so let me try and run this, and I see if it respects the new filters we've created. Application has started. Send a request. I come here. Yep, all the filters have been invoked. So there are still bins, and in case I remove this, you'll see that for sure they will not be invoked anymore. If I remove these bin declarations and the filters only remain Java classes, they're not going to be invoked during request processing because they have not been added to the servlet context. If I come here, only the controller is activated. So I'll just undo this comment. And now here we are. We can manage everything from here. And then we need to see for sure. What I forgot to show is whether the order was respected. So because you see, we can see here clearly, we've ordered the creation of these bins in the filter config class. But Spring doesn't really follow that approach. It has its own arbitrary way of ordering filters. So I'm not going to count so much on that, but let's see what happens. So we come here, front office is intercepted, followed by tech recruitment, EM1, EM2, EM3, CTO. So actually the order is good, but it's not very deterministic, it's not reliable, because anything can change here. Maybe I move the recruitment to above the front office filter, and the order might just change, and it should not really depend on how we're ordering stuff in our code. Because if I look at it here, now the tech recruitment filter is first, front office is first. So we're not going to count on the ordering of our class declarations or bin declarations to decide how our bins, our filters should be arranged. So this is supposed to be number 2. I'll make this number 1 all the way up to CTO filter, and this is going to be number 6. So that's good. Now let's see if our order won't be respected. Very certain it will be respected, because that is what we've just done is the most deterministic way to retain the ordering. So I come here. Okay, tech recruitment is still called first. So why is that? Because I made it number 2. Okay, tech recruitment is called first, front office second, the rest remain in order. So I expected the order annotations to work, but I'm seeing the tech recruitment filter is still created before the front office filter. So when I change the order like this, I'm not very confident that I'm solving the problem, because then it's just going back to the order in which the bins are declared in the configuration class. I don't think the ordered annotation is having any impact on that. So if I come here, front office is first, but by no means can I say that it's because of the ordered annotation. So I won't bank so much on that. But anyway, the main purpose for which I created the filter config is to add a different kind of filter creation, because this is basically just what we did before, only that we are declaring them as bins in a central place in the configuration class. But previously we declared them as bins from inside their classes by annotating them with the component stereotype annotation. So we've removed that in favor of keeping the bin declarations in one place. But now I'm going to introduce a new class called filter registration bin, which is this one. So it's a class that is used by Spring to create new filters. So basically, when we did this and added component here, Spring simply inserted these as ordinary bean objects, ordinary beans into the application context. But then after that, behind the scenes, it created filter registration beans for them based on all the parameters we added. For example, the order and all, they were all created inside an object called filter registration bean. And this is what is used to insert the the filters into the servlet context. So instead of Spring doing that, if we need more customization, as we mentioned, every time we have more complex needs, we may need to explore another way of creating servlet filters. And this is just one of them. Now we want to be able to make sure that when we have a tech application, it goes to a certain filter chain. And when we have an HR or finance application, it goes to the finance filter chain. It should not be, we should not have tech recruiters being active during recruitment of finance people. So how do we do that? Filter registration bean is a more powerful way of creating beans, and I'm going to show you how we shall do it. So if I declare a bean of type filter registration bean, so if I do front office filter here, well, this bean is a parameterized bean, so you need to provide the type of the filter. So I'm going to just put front office here, and I remove this. Then I come over here. Okay, I say new filter registration bean. I create it with the front office config, and then I can configure it. Now we've created a new filter registration bean. Now I can configure it. I'm going to set filter, new front office filter, bean.set, bean name not necessary. I'm going to set some other. Oh, you see, order, this one should come first. Now that's a more imperative way of setting order. Then set, there's another parameter I need. Oh yes, so URL pattern, set URL pattern. Let me see, and okay, I just want that varargs version of the method, add URL pattern. So I'm going to say it should only apply when we do tech recruitment, right? Okay, so then return the bean. So I just want to test this out. I've replaced the front office filter with tech recruitment I've replaced the front office filter with a filter registration bean declaration, which also exposes the same bean really, but it gives us more power. Just like we've seen, we can now specify which request path should trigger this filter. So I'm going to come and restart the application. All right, it has started. So let me first send the request and I see what happens. It's successful. When I come over here, now front office filter is the first to be intercepted. Even if I change the order of declaration, so I'm really feeling like the order annotation, maybe there's something I don't understand about it, but I've used it before, and it's just now that I've noticed that it didn't really order the beans the way I expected. It didn't order the filters the way I expected. So you see, even if I put tech recruitment filter first, front office filter comes first, because the new approach we're using of declaring the filter in a filter registration bean is actually being respected. And furthermore, I have added a URL pattern here. So front office filter it intercepted the request because the request was following this URL pattern. So let's test our hypothesis that If the request is going to a different route, then the front office filter will not be activated. So when you see finance application received in controller with comments, there's a tech recruiter comment, EM1 comment, EM2 up to CTO comment. However, there is no front office comment. So when you come here, now we can't see front office filter anymore, right? So I'm going to use this same approach to make sure different pipelines are activated. Now, one thing I should mention is that by default, the filter registration bin applies to all, by default, it applies to all requests, right? By default, it applies to all requests. I can't see that here. However, when I mentioned earlier that the first ways that we declared our filters resulted in the filters applying to all requests. So the reason is, behind the scenes, if we don't specify a path pattern, then Spring or the servlet context is going to put that filter in all filter chains that are attending to requests. So we've just changed that by configuring a path pattern for a specific filter, which is the front office filter. But for now, let's explicitly make the front office filter active for all paths. So when we do this, we are saying cover all paths in this application. Then we come to the front, the tech recruitment filter. I'm going to use the same approach to define it. I'm just going to do this tech recruitment pipeline. Yeah, all our filters are here. We can do away with this order annotation. It wasn't giving us much progress. So now I've added path patterns for all of them. And as you can see, this is the only thing that we've been able to achieve properly with filter registration bin. And of course, besides the failed ordering, but filter registration bin, I think, can do more, but this is all for our purposes. Now let's test out our tech recruitment pipeline. When I invoke that, tech application reached controller. So when I come over here, you can see that the front office filter is invoked. Tech recruitment goes to EM1, EM2, EM3, CTO. And just to rattle the boat a bit, if I wanted to change the ordering, and I make the tech recruitment number 1, and then front office number 2, I just want to give you the confidence that actually this ordering inside a filter registration bin actually works. So when I send that request again and I come here, and then you will see tech recruitment is now number 1. So I hope that is done and dusted. We can change it back to front office number 1, tech recruitment number 2. Perfect. So let me just restart that. Now I want to add a control test to make sure that because what we expect is that after adding these paths, then the filter is not going to be, the filter chain will depend on the path. So if we make a call to the finance application endpoint, yes, so remember, now only the front office approves. Only the front office comment was added. So if you look at the logs, you'll see that the front office intercepted, then the finance controller intercepted, then front office intercepted the response. Now, none of the other filters were active during this time. If we wanted to add the tech recruitment filter in the finance pipeline, I could do this. I could say finance. Then I would just start my application. And now, instead of seeing only the comment from the front office, I could see a comment also from the tech recruiter. But we're just really testing something here. This is not what we really want to do. I just wanted to show you how we can manipulate that. So I will remove this. And yeah, now the next thing I'll do is to create a finance recruitment pipeline. So let me just rename this to, tech filter config. Okay, take filter config. Then I'm just going to copy everything here. And I'm going to create finance filter config. Come here, finance filter config. So what I'm going to do, I'm going to create other filters for finance, starting with FM1 filter, finance manager 1 filter. Boom. So now there goes our first filter in the finance pipeline. Let me just rename these to finance pipeline config. I'll change the tech recruitment for tech pipeline as well. Tech recruitment pipeline config. So now the names are a bit more aligned. So I will create more filters for finance, including FM2. So we have all our finance filters here created, and the last is CFO filter, Chief Finance Officer, CFO filter. Okay, let me just import that. The path should point to finance endpoint, and yeah, I think we have them. Now, since in any case, the first filter that will be invoked is we want the front office filter to be invoked first in all cases. So we have this one. Is it the finance manager first? Okay, finance recruiter first. We'll take this one up to here. And then we'll make sure it's order 2. Then the finance manager filter will be order 3. This one will be order 4. This one will be order 5. And CFO will be order 6. So yeah, we have the finance pipeline here. We have we have tech recruitment pipeline over here. Well, unfortunately, we have so since front office filter is common to all, let's move it to another config file. Let's call it main config. Alright, I'll label this as a configuration file. And then I have the front office filter here. It is at position 1. So I think everything is good. There's something else I want to change. The logs are becoming too noisy. And since we already understand that really either way these filters are going to be invoked, I just want to make sure that we can, not make sure, but I really just want to clean up the excess logging. Maybe let me first leave the interception logs there a bit, but definitely not the return logs. The response log is going to be too noisy. I'm removing them. Could have centralized all this stuff, but it's alright. So I'm removing the response logs because they are no longer adding anybody here. We understand what's happening. I come to so finance manager will I need logs for finance. So I'm going to log info. Let me have their marker as okay. Yeah, that's good. And then I want to go to the controller. So just like in finance application sent back a list of the comments accumulated during its invocation, I'll add one here for the tech recruitment. So I also need to inject the HTTP servlet request over there. Yeah, I think the application is ready. Now, when we invoke the tech application, we expect only filters that are in the tech pipeline to be active. And when we invoke the finance application, we expect only filters that are in the finance pipeline to be invoked. And then I'll add a third API here, HR application. So for this one, we shall use it as a control, and I want it won't have any filters on its path. Reason being, it will only have the filter that covers all paths, and that is the front office filter. So I'm going to just copy these 2 lines, add them here. HR received in controller with comments. So I'm returning HR application received in controller with comments that. So now I think I can start the application. Restart. All right, so I come to Postman and I call finance. All right, so look at the comments and the order in which they appear. Front office approves of this. Finance recruiter viewed. Finance manager 1 viewed. Finance manager 2 viewed. Finance manager 3 viewed. CFO viewed. So definitely our new changes are working. So when we call the finance application endpoint, only the finance recruitment pipeline is activated. And remember, front office is at the front of each pipeline. All right. So let me call the tech recruitment application endpoint. All right. Look at the order of filters. Front office is again at the top here, followed by tech recruiter, EM1, EM2, EM3, and CTO. Then if I call the HR pipeline, HR application, only the front office approves of this. So now we've just covered the concept of filter chains in the way that works by default, right? This is something that may be a bit confusing. Reason being, we've not really created a chain as such, but we've seen that what we've been looking for all along is happening. We've not really created a filter chain. We've not gone to create a class that is a filter chain. We've simply injected bins and we've added paths for them. We've qualified them with paths, with their API endpoints that should be targeted. And that has resulted in a pipeline or a filter chain being created for every different path we've had: API finance, API tech, and API HR. So this is basically the idea behind filter chains, that you can group a set of, you can have a set of filters working together to intercept a specific category of request that when it arrives, the servlet container will be able to know, okay, for this particular API endpoint or path pattern, I should activate these filters. Then during the process of bootstrapping the servlets for servicing the request, it will create a filter chain on demand, and this filter chain will be invoked. So when a finance API call arrives, when a finance application arrives, then a new filter chain will be created. All filters that qualify for this path will be added to that filter chain. I'm going to show you how this works. Now, there's something else I want to do. If you can see in the finance recruitment pipeline, we have about one, two, three, four, five. We have five filters, and you see there's a lot of cumbersomeness. We're repeating the same thing over and over everywhere, and even the tech recruitment pipeline has about five filters. Add the front office filter on top of that. We're dealing with around 11 filters in all. And for each pipeline, we are creating the filters the same way. So behind the scenes, what's happening is that when we declare a filter as a bin, like we did here and we did in the other places, Spring will add this filter into the application context, like any bin in the application. And after adding it, later it will look for all bins in its context that are of type filter. And all our 11 filters will qualify for this. After locating all of them, then it will just add them into the servlet context. So the servlet context has a method called, so let me first do this. Let me just show you something. Servlet context. Let me implement the servlet context aware interface. This will provide us with the servlet context. So if we have the servlet context, I can do this add filter. So servlet context has a method called add filter, and that method takes the filter name and the filter class, or the filter instance of filter name and the class, and then it will create the filter behind the scenes. I just wanted to show you that. So remember that when we declare these filters behind the scenes, Spring will add them into the servlet context, just the way we've seen. But they'll still be Spring bins, but they are added into the servlet context as mere filters, just like we've seen. So one challenge with this is that these filters are completely invoked by the servlet context. Remember, they are invoked before the dispatcher servlet, before the request reaches any Spring bin. All right. So the filter chain is invoked. The default filter chain in which all the filters are added for a particular request is invoked before the request reaches the dispatcher servlet. So all this is controlled by the servlet container. However, remember, we are dealing with Spring, and Spring has a whole host of powerful features that we rely on, like the dependency inversion feature. We have the AOP, aspect-oriented programming, and a couple of things that servlets are not able to do, otherwise we wouldn't have Spring. Okay, Spring is powerful like that, and we would like to ideally keep everything inside Spring. However, filters are a servlet specification component. All right, they don't belong to Spring, but we want to use them. So there's a way we can have the best of both worlds. Filters are a servlet thing, but we have this powerful framework called Spring. And within the Spring framework, we would like to manage our servlet filters without having to depend on the servlet container. We would like to use the Spring application lifecycle events and all this. And just to make sure everything is within the same, dealt with within the same application context in Spring. So this is a concept that is used heavily in Spring security, where we rely on servlet filters, however, within the context of Spring. Okay, just like I've told you, when this bin is created in this application context, behind the scenes, it is then taken plus all the other filters and they're added into the servlet context, and they stop being used as Spring bins as such. Okay, so what I'm going to do is to create another mechanism of achieving this servlet filter chaining that we achieved, such that for finance applications, only the finance pipeline is activated, and for tech applications, only the tech recruitment pipeline is activated. So without having to do all this writing. of code. So how do we get the best of both worlds? Number one, we still need a way. We don't need to have all these 11 filters inside the servlet context. Okay? Remember, filters are just an implementation of the chain of command design pattern where we have an action method which receives parameters and then the chain within which it's executing. And after doing what it's doing, it delegates the request back to the chain. Then the chain will know what component to invoke next to complete its execution. So this is not something which is unique to servlet specification or to Spring. However, this is the chain of command. It's one of the top design patterns. All right, we could even create our own following the same, but filters and filter chains already implement this very well. So I'm going to stop the whole idea of adding each filter into the servlet context, right? I just want to add one filter to hook us into the servlet context, right? I want to create a filter of, should I create it in configs? No, since we had a front office filter as a central filter, let me create another filter to be a central filter here. I'm going to call it filter proxy. So filter proxy is still a filter. It's a filter. And let me call it a component. Okay, so it's a bin and it's going to be added into the context. Do filter. So like I've told you, it's just a filter with any other, like any other filter. I'm calling it a proxy filter because I've just told you I don't want to add all the 11 filters inside the servlet context. I just want to have one filter so that it can be added. Like I've just told you, all the filters we've been creating are added behind the scenes by the Spring initializer inside the servlet context. So I only want one to be added because if we don't get it added there, then there won't be any invocation. It needs to be added into the servlet context so that it's added into the chain, and the chain of it's added into the default application filter chain. And when it is invoked, then I want it to do something such that all our other filters are invoked as well. All right, that's why I'm calling it a filter proxy. I don't want to depend on servlet context 100%. I just want to put a leg inside there so that I can intercept requests here that are coming from the outside world. Then when I intercept them here, then I can forward them to Spring. That's why it's called a proxy. All right. Then next I'll create another class to also proxy filter chains, okay? Because I just want to wrap the functionality inside classes so that I have control over them. So I'm going to call this filter chain proxy. So filter chain proxy is still a filter. It's a component, then it's a filter. Implements filter. And it implements the do filter method. But I want it to contain some other two public methods. So there's a method called matches. What I want to do is it will receive a servlet request. I want it to be able to tell whether this request should, whether this chain should apply to the request. Then I'm going to, all right, so let me just return to here. And I'm going to create another method called list. So get filters. What it does is that it should return a list of filters. So let me see if this makes sense. So filter chain proxy is also a proxy for filter chains, but remember it has the do filter method because its filter instance. Actually, I think I'm a bit wrong. I think this should be, I should make this a filter chain because I'm trying to proxy a filter chain. So filter chain proxy. Let me add the implemented methods. I remove this. So now a filter chain has the same do filter method, but only with the request and response. It's the one that adds itself as the third parameter when invoking the filters. So after implementing the filter chain, I need to keep a list of filters. So let me just create an empty list because we said that a filter chain can contain 0 or more filters. So I'm just going to leave it as an empty list, and I'm going to create something else. So I'll return the filters here. The next I need to make this method work. I need it to be able to compare the request with a known path that this filter chain is supposed to be active for. So let me do this path. So by default, the path will be that. It will be active for all paths. So let me now create a constructor filter chain proxy, which takes a path and a list of filters. So path. Yeah, now I have this, and we create a path matcher so that I don't have to do the code myself. And what I'm going to do here is matcher dot match the pattern, then request dot get request. Okay, I need this to be an HTTP servlet request. HTTP servlet request. Request URI. Okay, so I think our filter chain proxy is ready. Okay, I don't need this. All right, no problem. So our filter chain proxy is ready. So what I'm going to do, I just want to loop through the filters and invoke them one by one. So I have a list of filters here. What I'll do, I'll keep track of a static counter. Started at 0. So I'll come over here. So let me see, let me start it at -1 so that I increment it at once and it will go to 0. So I want to check if filters says if filters is not empty, and counter is less than size. So filter is not empty, that means we have some filters and we've not reached the last index in the filter. So I'm going to do this. I'm going to say filters get increment the counter before, but do filter request response. This, I'm passing in the current chain. So when it invokes the filter, that filter will invoke, when it invokes this, it will pass itself here, then the filter will call do filter again, and we shall keep checking, and the last filter to invoke will result in this block being called, but beyond that, the last filter to invoke will result in this block not being called, and then the method will exit. And I guess that is it. So then I have my filter chain proxy, and I go to the filter proxy. What should the filter proxy do? The filter proxy should have a list of filter chain proxies. So I'm going to say, and I come here, I call this filter proxy. Filter proxy will take should it take a list of filter chain proxies? No, it doesn't have to. So I'm going to create a public void add chain filter chain proxy, and this will just come into filter chains add chain. I think this will do. So the filter chain proxy will be invoked, and in the do filter method, of course I will have to do this, but before I do that, to pass the command onto the next filters in the chain, I'll have to invoke my appropriate chains. So I'm going to look through filter chains. Okay, let me try something here. Chains don't find first. No, it's not appropriate. I need to get filter. So how do I filter? So I'll do the, let me see. So I'm filtering filter chains. It should match request, the ones that match request. So let me change this to HTTP request. So I want to convert what I have here into an HTTP request before sending it over into the filter chain. So I have an HTTP request. I'm going to pass it here. And why is my chain failing? Variable chain is already in the context. So I'm going to say filter chain proxy. So I need to find the first filter chain proxy that matches. I'll call this maybe match. So what I'm trying to do is to find the first filter chain proxy among those I added that matches the current request. So maybe match. And when I find it, maybe match dot is present. If it's there, then I just do get dot do filter request response. Basically that's it. If it's not there, we continue. If it's there, either way we run the filters inside there and continue. So now I have my filter proxy. So this right here is what I need to add inside the servlet context. So I'm going to make sure this is not a bin because I want to control the creation. And then I'll come to my main config. Is it? Okay, recruitment pipeline. I want to create a bin of filter proxy. No, it should be there. Filter proxy is a cross-cutting concern. It applies to all. So main config, I'll create a bin here called filter registration bin, then filter proxy, and then call that filter proxy. I'll make these type changes over here. Order 1, so it applies to all requests, okay, because it's the one that simply goes in and checks. It has to be able to intercept all requests since it's the only filter we're adding into the servlet context. So now this front office filter definition is useless. I can remove it. I have my main filter over here. So I come to the filter chain proxy. Now I need to create instances of filter chain proxy for each of my pipelines. When I come to, let me remove this, that. Now I will go to finance recruitment pipeline. Instead of creating each of these filters one by one, I'm going to do something like this. I'm going to expose a bin chain proxy. Okay, filter chain proxy. Okay, let me just, I'm getting other ideas, but let me first do what I have in my mind. So I have this here. What I'm going to do is I'm going to create a new chain, filter chain proxy. What are the parameters? Okay, path and list of filters. So the path is going to be API finance. And then I need a list of filters. I'll call this filter. And then what I'll do is also, I just need something generic. So now, what I've just realized that I need to do is to make this generic. Let me first go back to the filter chain proxy. And make it generic so that it can accept items of type T. Okay, so this should be a list of type T, where T is anything that extends filter. And then here we return type T, a list of type T. And yeah, that's it. That's the only change we need to make here. Then we come over here. Now I have a list of type filter ready. Okay, how do I do this? All right. Screw that, I'm going to do this. I'm just going to say add filter. Oh wait, didn't I add that method? Okay, it was add chain, so filters.add filter. So now I don't need a list. I don't need a controller that adds a list as a parameter, so I can remove that. And I come back here, I just create a filter chain with path, and then I add the filters one by one. Finance recruitment pipeline, I can delete it from here. I have FM1 filter, and delete it from here. Then FM2 filter, I can delete it from here. Then I have FM3 filter, I then delete it from here, don't need it anymore. I have CFO filter, I delete it from here. So then we can then just return chain. Now, what are we going to do about ordering? Let me just check to make sure. Wait, oh, okay, I added, I just need this to accept anything that is of type filter. All right, so what's this? Okay. Filter chain proxy. No, that's not correct. Okay, let me just leave it like that. If I get problems, I'll come back to it. Now, what I need to do next, basically, I've added all my filters, so the ordering bit is going to be like this. So here, the only thing I need to add is the front office filter. The rest are in order, in the order in which I want them to be. Now I come to tech recruitment. Let me just copy this bin declaration. Nothing will change. So all these, I remove them. I just expose a pipeline, a chain. So this is tech pipeline. Tech, so I'll have here, front office will still be there. Then I have the tech recruitment filter. I'll have the EM1 filter, EM2 filter, EM3 filter, CTO filter. Okay, so everything looks good. Now the moment of truth is here. Let me just check to make sure everything I can detect now, I detect it. So I have my tech pipeline. All is good because I create a filter chain and I added the filters to it, but I've not yet added this chain to the filter configuration. Then I come here, I created a recruitment filter chain for finance. Good, it's a bin. And I come to filter proxy. I have not added the chains. So what I need to do is in the main config, I need to add filter proxies here. I had started to add it and set order 1. So what I need to do is create this filter separately. I create my proxy filter here, and I have to inject my recruitment pipelines. I have to inject all my filter chains. So I can just say I need a list of all the filter chain proxies inside this application. So regardless of the order they're in, I'll only take the first one that matches. So I know I just need to. Yeah, I'm supposed to have a controller. Oh, sorry, I didn't. I'm supposed to have a constructor that takes a list of proxies. Filter chain proxy. So I come here, filter chains, let's go to chains. So I really don't know what I'll do about all these generic errors, but let me just first see how this works. So now I have my filter proxy. It takes a list of filter chain proxies. So I can do this without creating a separate call. So I have my chains there. So this list will be aggregated from all the filter chains. I'm registering it here. Okay, remember I didn't declare it as a bin. I didn't add any. I shouldn't add this because I'm creating it from the configuration class. And I have my filter chain proxy, which will be added to the servlet context, and it should receive a list of filter chains. Filter chain proxies here. I come to I've created the proxy for finance and proxy for tech. So when the application starts, I'll receive a list of them here. I add them to the filter chain, filter proxy, and that'll be it. So moment of truth, let's test it out. Alright, so it has failed for whatever reason. Let's find out why it has failed. When you write code for so long and then you test all at once, this is what happens. You're supposed to test, write code and test in bits. So I have a null pointer. Let me check. Okay, filters.add filters is null. So what this means is that when I create a filter chain proxy without the list of filters, I should make the list empty. So now let me restart and we check the rest. Yep, time to test. Oh, it has started. All right, that's a bit good. All right. HR application received in controller with comments. I'm anxious to check the logs. Oh, wait, HR pipeline was not added. Okay. All right, let me go and check tech. Okay. All right, there's an internal server error. Let's see if my generics are the problem. All right, it's an index out of bounds. So now, do you know why this index out of bounds is happening? Because I checked if filters is not empty and counter is less than filters.size. Okay, that should be fine. Only that when counter is less than filters.size, it should be after I've incremented counter. Right, I'll keep that there and I remove this here because I check here if counter is less than filters.size. So if filters is size 6, a size 6 list, this if condition passes, but it messes me up when I'm trying to get the actual element at that index because I increment it after checking. So I should increment it before checking. All right, so I will try again. Hopefully that is the only bug, but if there are more, then we shall see what to do. Okay, so I come over here, I send a request. Yes, it has worked. It has worked. So front office filter, tech recruitment filter, EM1, EM2, EM3, CTO. Yes, and then when I do finance, let me see if it works. Oh, finance is null, so finance has failed. I don't know why. Maybe it's because one of the filters didn't really, one of the paths didn't match. But if I come over here and I look at finance, I quoted the path well. I added the filters well. It's a configuration class. I have the main config. I injected all the filter chain proxies here, and finance pipeline is okay. Tech pipeline is okay. So what could have gone wrong? Right, so I'm just going to investigate this briefly. Okay, so I think I know why in the finance recruitment pipeline, comments is null, because we're supposed to get a list of comments from all the filters in the pipeline. So let me come over to here. All right, so recall that in the filter chain proxy, I have a counter, which is a static counter. So I'm supposed to make this an instance counter, because when it's a static counter, it will be incremented for all instances of the filter chain proxy. It will apply to all of them, because I should make it let me just refactor that. I'll make it lowercase. I remove the static keyword, so that here it will only be incremented for an instance of filter chain proxy, because remember, I added chains. I injected the filter chain proxy instances here, and if I keep this as a static variable, then for each it will be incremented globally, and that affects this block of code. It will not execute for finance. So let me just try that fix, hoping it works. All right, application started, so I'm in finance. When I send that request here it worked. So I have a comment for front office, finance recruiter viewed, finance manager 1 viewed, finance manager 2 viewed, 3, and CFO viewed. And if you come to the logs over here, front office happens, FM1, FM2, FM3, and CFO, and then the finance controller. So if I go back and I change this to tech, I don't expect a null. Yep, tech comments, tech recruitment pipeline happened. So you can see here. Great, so that worked like a charm. I should remove this useless constructor since I'm not using it anywhere. Main config, everything good. Yep. So just to recap what we did, we have one filter, which is a filter proxy, that we've created as a filter, a servlet filter, like we did before when we created very many filter instances here. So now we only have one filter proxy, one filter that is added into the servlet context. And what that filter does, okay, let me just remove this other useless assignment here, setter method here. Okay, so what this filter does is that when it is added into the servlet context, it is the only one that will be in the application filter chain in the servlet container. And when the servlet container invokes it, Then what it does is that it looks for all the filter chains, all right, inside its filter chains variable. Remember, when we create it, we insert a list of filter chain proxies here. So these are filter chains for different pipelines we want to implement in our application. So in the doFilter method, for each request, it looks for all the filter chains that are applicable. Actually, it filters them out and selects the first one. So that means that if you have more filter chains that match the finance recruitment pipeline, or that match the tech recruitment pipeline, only one of them will be selected. All right. So, and I mentioned earlier on that typically you just have one filter chain that is going to execute. So this means that you should make sure that for each path there is only one filter chain. If there is more, then this thing we've developed is going to fail, because it will only select the first one that matches. And what happens is that after it selects that match, it simply invokes it. It invokes the doFilter method of the filter chain, and the filter chain's doFilter method simply loops through. It doesn't really loop through, because the looping is supposed to happen based on the chain of command pattern. So it invokes the first filter after incrementing the counter, and then that filter is the one that invokes doFilter again in the chain, because remember they're chained. Like if we go to the CTO filter, it does what it's supposed to do, which is just adding a comment, and then calls the chain.doFilter method. And the chain is our filter chain, which is the filter chain proxy that we added. So when it's invoked again, it increments the count again and invokes the next filter in the chain. And this goes on and on until the last filter is invoked, and then this doFilter method exits. And when it exits, the main filter chain of the servlet context will be invoked, or the servlet container will be invoked. And if indeed our filter is the last one in the chain, in the main chain, then the request will proceed to the dispatcher servlet. So this is a summary of what I wanted to show, and it will be good for you to realize that this is exactly the approach that is used in Spring Security, and I'm going to show you how this works when we start really digging into Spring Security. So thank you very much for following.